In this video, we'll be starting to talk about function transformations, and first we're going to talk about one of two types of rigid transformations, which is shifting graphs. Now, as far as transformations, we can actually think of most functions graphically as transformations of those few parent functions we talked about in the last section. Namely, transformations come in three basic varieties, and we'll have a video on each of these. So in this first video, we're going to talk about vertical and horizontal shiftings, which means we either add or subtract a c on the outside or add or subtract some constant on the inside of the function. Reflections in the x and y axes will be our second video. Namely, you apply a negative on the inside or the outside of the function. And finally, scalings will be our last video, and that involves stretching and compressing, or as the book calls it, shrinking the graph. As such, these are called rigid transformations, and these are called non-rigid transformations. And basically the reason for this is rigid transformations don't change the how the graph looks, but these do. Now, as far as vertical and horizontal shifts are concerned, which is our first type of reflection, these can also be called translations sometimes for c, but we're going to go ahead and let c be a positive number, and we can shift the graph of f of x the following way then. We can either vertically shift it up by c units, and that's by creating a new function where we took the graph of f of x and we added c to it. We could also shift it down c units. Well, that would be by taking f of x and subtracting c on the outside of the function. Here, a horizontal shift right by c units is by subtracting c on the inside. And here, shifting it left by c units would be by adding a c on the inside. So this is best understood by example. So for example, let's use the parent function f of x equals x cubed to sketch the graph of the following two functions. Here we have, so it's helpful to write some notes down when doing this. So here we have x cubed, but then we subtract 1 on the outside. Subtracting 1 on the outside of the function, that is basically here what you have is this. If you were to look at it and substitute f of x in, this would be f of x. This is f of x equal, this is really f of x minus 1, okay? Well, in other words, that means we shift down 1 unit. Well, to shift down 1 unit, that means we'd just be taking this whole graph and shifting down here. So all the points get shifted down. And so now the graph looks like this. This would be the shifted graph. Okay. So, like so. Over here, what do we have? Well, here we see that we actually added 2 on the inside of f, because then it's all cubed. So that's f of x plus 2. But then we added 1 on the outside. So that means, what did we do? Well, we shifted it left. We shifted it left by 2. Left 2 units, and up 1 unit. Well, if that's the case, we can start with the center point. That shifts it over 2 and up 1. This point also gets shifted over 2 and up 1. This point gets shifted over 2 and up 1. This point gets shifted over 2 and up 1. And then down here, over 2 and up 1. So if we redraw our graph, it should look something like this. Okay. And there you go. And now it's your turn to try an example, so go ahead and use the graph of f of x equals x cubed as provided for you to sketch the graph of the following functions, x cubed plus 5 and x minus 3 quantity cubed plus 2. On the count of 3, I'll reveal the solution. 1, 2, 3. So as you see here the graph of f of x is going to be shifted up by 5, so we get that graph. And over here, the graph gets shifted up by 2, but to the right by 3. So over 3, up 2. If you'd like some more practice in working with shifting around graphs of functions, be sure to see the textbook. The following problems, it's kind of a weird way. They sprinkle a lot of different problems together in this section. But in our next video, we're going to be talking about how to reflect graphs.